All right, well, I hope everyone had a good lunch. My name is Jessica Andrews. Obviously, I'm not George, so I'm sorry if that's who you were expecting, but he kind of got himself a little overscheduled, and so I'm here filling in at the last minute. So hopefully you'll all forgive me if I don't quite do his presentation justice. But I've been with UDOT for about 7 years now. I started as an intern. Now I'm an engineer. I went to the University of Utah, graduated from there. I used to work in maintenance. I did part of their culvert inventory program. And now I'm working in project development in standards and design. So today I'm going to talk to you a bit about our quality control and quality assurance procedures. So I'd like to just kind of start off with talking about what exactly is quality control and quality assurance. Well, we like to define quality control as a set of procedures performed by qualified individuals intended to ensure that a product or service adheres to a defined set of quality criteria. So basically, you want to have someone who's qualified, which means that they have experience in that area, they know what they're looking for, and you're going to have them check to see if you've made any mistakes, make sure everything's done correctly, also make sure that nothing's left out, nothing's been neglected. And then we like to define quality assurance as the process of maintaining a desired level of quality by monitoring all the stages of the project and validating quality control procedures. So basically just ensuring that your quality control check has been done correctly. And it's just basically a process to ensure you have a quality product as your outcome. Why is a good QC/QA check important? Well, the purpose of a QC/QA check is to assist the project team in creating designs that are safe. They want to be economical. They should be constructible, maintainable, and then appropriate for their locations and surroundings. The QA/QC procedures assist the design team to verify that the design and project documents are produced with due diligence through the use of acceptable industry standards, appropriate techniques, available resources, and reasonable decisions by qualified individuals. These procedures are to be used as a tool, and they're not meant to replace the sound judgment and experience of competent professionals. It is the design team's responsibility to verify the quality of project documents before distribution. These procedures also act as a guide for personnel that maybe aren't familiar with the project and haven't been involved with the project, so that they can look back on the design process and understand why certain decisions were made, as well as just assist in finding any mistakes that may have been overlooked. A basic principle that we have in our QA/QC process is that if you didn't document it, you didn't do it. There's an example we like to use, how say if you have a project and you need a flagger on that project, well, someone obviously would call and arrange for a flagger. And then once you get to that project, your flagger doesn't show up. So if you didn't document who you spoke to, when you spoke to them, you have no one to call back and say, hey, what's going on? I don't know where my flagger is, and the project gets delayed. So it just shows that even something as simple as a phone call or an email should really be documented, just so that you have it for future reference later on. And we just like to emphasize that documentation is a crucial part of the process. Our QC/QA protocol is what I'm going to talk about next. We have a very specific protocol to ensure that everything is documented correctly, and that UDOT has provided designers and consultants with a standard protocol containing these 6 key tasks that we're going to talk about today. And they are documenting and archiving decisions, compiling documentation for a QC check, preparing design check prints, preparing QC checklists, quality assurance, and then uploading all of that QC, QA check data to ProjectWise. As I said before, one of the reasons why we need to document things is because sometimes when we make a decision, the reason why can be easily forgotten. Anything as simple as an email, phone call, face-to-face conversation, it should be documented and saved in an easy-to-find place if it's something that you think you need to reference in the future. So here we have an email as an example. At the bottom, we have our designer emailing our maintenance shed, talking about that there is a need for barrier through multiple locations throughout the project, and asking if there's a specific type of barrier that they would prefer, or if there's any problems with any types of barrier that they've had in the past. And so our maintenance sheds replied back to our designer, stating that they would prefer guardrail be installed, and they would also like to use steel posts instead of wood posts because they've had problems with pests and decay in the past. So even just something as simple as this, just document this email through an email archive. You can use phone log, meeting minutes. There are many ways to just document your information. And so that also brings about the question is, what exactly would you want to document? And, just basically any basic info that you think would be important. So let's use our same email example. We have when our decision was made, which is September 27th. We have what it was regarding, which was our state route barrier. We have why it was made, because the pests had wood decay in the past. We have who made the decision, which was the designer, the UDOT maintenance shed, along with the UDOT project manager. And then we have where this decision is going to affect the project, which is along the entire length of the project. Once you have all your documentation, the designer should organize it so that a QC check can be completed. A QC check comment form must be filled out. A print of all documents must be made for the check print process. All applicable QC checklist should be reviewed. So this image here is showing an example of our QC check comment form. And it's using our same guardrail example that we've been talking about. And it has all necessary references. It includes the email between the design team and the maintenance station and which folder it's located in. And it also includes our length of need calculations and where they're located as well. Here's an example of a portion of the QC checklist for the roadway design section. This checklist is modified to only include items that relate to the guardrail design. Items that aren't applicable are marked as NA. The designer should review the checklist before submitting it for QC. They should make sure that all aspects of the design have been accounted for, and anything marked NA really is not applicable. These checklists serve more as guidelines, so it's really up to the design team to decide what they need to add, what they need to modify, and what really is not applicable for the specific project. Check prints are an essential step in many project deliverables, such as plan sets, engineer estimates, design calculations, etc. It makes it possible for other individuals to go back and see what mistakes or changes or decisions were made throughout the process. Since this is a check of someone's work, accuracy and following the procedures is critical. It also makes it easier for someone not included in the project to follow all of the changes throughout the process that led to this final deliverable. So UDOT has a color-coded QC process for check prints. Our first step is we have our originator who will print out the check print in black ink. Then we have a checker go through. They'll use yellow ink to highlight any items that are correct. They'll use red ink for any items that need to be changed or added or deleted. And then they'll use blue for any comments or clarifications or just suggestions to the designer. So you can see we have our example on the right. Additions is correct, so that's highlighted in yellow. They're suggesting to they're suggesting to move corrections to the right in the blue, and then they are changing corrections by adding an R and then deleting deletions and changing it to changes. So then we have someone who is a back checker come through. Oftentimes it's the originator of the document, and they'll go through with a green pen, and they'll either mark a check mark for the changes that they agree with, or an X, and then they'll write STET for the changes they don't agree with. So you can see in our example, they agreed that they should add in the R and move corrections to the right, but they didn't agree with the change to cross out deletions and write change. Then the originator then goes through and then changes the items that they've decided to change. So they decided to change the corrections and then move it to the right. And once they've made that change, they circle it, indicating that they've looked at it, they've made the change, and that it's done. Once that's all done, they send it to someone who is a verifier, and they will check all the previous corrections to make sure that everything was done correctly. And if it is, then they'll highlight it in yellow. So you can see why it's important to follow these specific steps so that the person verifying your document knows exactly what changes were done and can follow exactly the process of how everything was changed and how it became what it is now, which is at the bottom where we have corrections on the right, spelled correctly, and additions or deletions. So going back to our same guardrail example, here we have a sample of our length of need calculations. So our originator has printed it all off in black ink and submitted it to the checker. The checker has gone through with the yellow highlight, highlighted everything that's correct. And then once they get to the bottom, they've found out that there's a mistake in the math near the end, so they've corrected that. And so then that gets sent back to the originator, who then goes through and either agrees or disagrees with the calculations, so with the changes. So obviously they've agreed because now the calculations are correct and they have a check mark. And then they'll go through and make those necessary changes and then circle it in the green pen to let you know that that it's been changed. And once that's done, the document then goes through the verifier, who can easily follow the steps that have been made to make the changes because everyone's used the correct process. And they'd verify that it's all correct by highlighting it in the yellow highlight, and then printing out the new copy, which is correct, and then making sure that the final printout matches what was verified. And then once that's done, a check print stamp is added, and everyone who was involved in the process doing the checking will sign and date. The QC checklist is a guide to make sure all areas of the project have been reviewed. Items that aren't necessary are marked not applicable and should have a reason why. Project-specific items should be added to the checklist. Checklist should be modified to most appropriately fit the project. The QC checker then checks each item on the list, making sure that any items that are marked not applicable really are not applicable, and also making sure that any items weren't left out, which is also why it's important to make sure you have someone who's experienced checking your document. Yes. Oh, yes. Let me pass that around. All right, so once our QC process is complete, the entire package is ready for a quality assurance audit. A quality assurance audit form, which is shown here, must be filled out and signed by the auditor. The QA audit verifies that the UDOT QC check procedures have been followed and that all of the QC documentation has been submitted. So once we have all that documentation and all the procedures have been completed, it's time for the designer to upload all that documentation to the appropriate ProjectWise folder. This is done simply by opening the ProjectWise Explorer and navigating to the proper project folder to place your documents. So as you can see here, everything is placed in the 1135 project folder. Our QC checklist also has the proper naming convention for our document that should be uploaded, as you can see in the circle. So for this example, we're still using our guardrail example with our barrier calculation document. And so in this example, our PDF is renamed with the project PIN number, and then the design element that's being reviewed, which is the barrier, and then the date the QC was done. And again, it's the format will be shown in this QC checklist from before. Once your file's been properly named, then you just drag and drop it into the ProjectWise folder. Once the documents are in the ProjectWise folder, we need to make sure that they're attributed correctly so that anyone going through looking for these documents can easily find them if they need to look at them later. So to do this, we go to the Properties, right-click on the file, and then go to Properties. And then we'll open the Attributes tab. And this will allow us to enter in any of the project info so that we know which project this document's for, as well as the document type filter, the document type, and the document subtype. And again, these things, the document type filter, the document subtype, and the document type can all be found again in this QC checklist circled in the red. So let's talk a little bit now about what makes a good quality control, quality assurance check. There are many attributes that go into a proper QC, QA review. 4 of these that we're going to talk about today are, as I mentioned before, the individual checking your work must be qualified to check it. They must have experience in that area so that they can not only check for accuracy, but also that they can check for anything that might be missing or incomplete. A good QA/QC review should also provide documentation, creating an easily traceable narrative of the design process. Basically saying it shouldn't be difficult for someone who's had nothing to do with the project to come in and trace all your documents and see exactly what decisions were made and why and how the product kind of evolved into what it is. A good QC, QA review should be performed with a focus on design as well as construction. A good check should always consider how a project will be constructed and implemented into its surroundings. Also, a proper QC check can take a lot of time, so it's important that the design team complete a deliverable and pass it to the checkers with enough time that they can properly go through the documents and review all the work to the best of their knowledge. All these attributes can ultimately lead to client satisfaction and a continual improvement which are a necessary part of good quality control protocol. Let's talk about some common mistakes that are made in the QC/QA process that we can avoid. One is going in with the wrong mindset. It can be a common mistake. Oftentimes, design teams view QC/QA as just simply another box to check off, when really it should be at the forefront of the design team's minds. A deliverable is only as good as the effort that was put into checking it. Rushing the process is often a common mistake. Since QC/QA is often seen as a time-consuming and tedious task, there are often times when teams will rush through the checks. It's not uncommon to see the check prints, like we saw earlier, completely highlighted entirely in yellow, or even just printed off on yellow paper, which obviously makes it pretty difficult to tell what's been checked, and then makes it seem like the check really was just not performed properly. Skipping over documentation or skipping over any of the steps in the process is a common mistake, which can occur because sometimes it is so time-consuming. A checker could easily be tempted to just do the corrections themselves and skip over the process entirely. However, this should never be done, because not only does it make it so that others don't check the work as well, but it entirely skips over the whole documentation process. So for this point, I found a neat example that I wanted to share with everyone. Just showing how sometimes you don't always check what you think you do. So this is called the inspection test. So hopefully you can all see it all right. Basically, you're going to be the inspector, and you're going to treat the letter F like it's a defect in the sentence on the next slide. And so basically, your job is to count the number of defects or count the number of Fs. So let's see what you all come up with. All right, is that enough time? What did we all come up with? 3, 7? Anybody else? 3, 4, 5? Well, we must have some good eyes up there, because we have 7. So sometimes it just, I think this is a good example that just goes to show you that sometimes, no matter how accurate you think you are, sometimes you miss things, and sometimes you have a front row seat and you get it spot on. So, yeah, kind of a neat example. Anyway, back to our mistakes. Our last one that we're going to talk about today is ego. And we all know sometimes when people correct us, it can be kind of hard to take and, make us feel bad. And sometimes we get defensive, and it can be hard when a checker finds mistakes or makes changes to our design. But this is just to let everyone know, the QC/QA protocol is not there to make anyone feel bad or feel angry that they made a mistake. It's just here to protect everyone involved in the whole process and make sure that the best product possible is delivered to the client. So basically, to summarize everything today, when developing a UDOT process, these are some key guidelines that we'd like you guys to take away from this. Documentation is probably the single most important aspect of QC/QA. And just to bring up our old phrase again, if you didn't document it, then you didn't do it. So having that documentation in there is quite helpful. QC/QA is more than just another box to check. It requires a mindset to be present and active throughout the entire design process. It's not just something to kind of blindly go through and just check off boxes. The QCQA provides us with a traceable narrative of how a product evolved into its final form, which is extremely helpful for anyone not involved in the process to go back and check and see how the project started and then evolved into what it is now. And then also, a point to remember is that as much as we stress this QCQA procedures, it's important to remember that it's only a tool, and it's more like guidelines and should never replace the competency or experience of a qualified individual. So that's always important, and brings us back to how you want to make sure that someone checking your work is qualified to do the checking. So yeah, that's basically all I've got for you. So if you have any questions, I can try and answer them or pass them along. So, yeah. What's that? Yeah. Oh, yeah. Yep. Well, I guess you guys all get out of here a little early then.